Elon Musk has finally spoken publicly about the three ISATs, and what he revealed has sent ripples of concern through the scientific world and across social media platforms globally. In a rapid sequence of posts that spread almost instantly, Musk, leveraging SpaceX's sophisticated tracking infrastructure and its direct coordination channels with NASA, claimed to have identified a development that, according to him, the space agency has not openly shared. The trajectory of the object known as Atlas has changed. Based on Musk's interpretation of SpaceX tracking data, Atlas is no longer following what would normally be considered a harmless flyby route. Instead, he claims it is now moving along a path that brings it alarmingly close to Earth's orbital zone. According to his calculations, a potential collision window could open in roughly 28 days. Musk was explicit in his wording. He stated that the probability of impact is not zero and is rising. He further asserted that NASA is aware of this risk, but is withholding the information to prevent widespread panic, even though, in his view, the public deserves transparency about what may be approaching. To support his claims, Musk shared SpaceX tracking visuals that appeared to show Atlas performing repeated, structured course adjustments. These changes, he said, have altered its path by millions of miles over time, steadily nudging it closer toward what could become a direct intercept with Earth. What makes his warning especially unsettling is that he did not stop at raising concerns. Musk announced that SpaceX has already begun developing emergency response concepts. These include potential missions designed either to change Atlas's trajectory or to deploy defensive measures. When an individual whose career is built on constructing and launching spacecraft begins openly discussing real-time planetary defense, it naturally commands attention. Musk has earned a reputation for dramatic statements in the past. However, dismissing this warning as mere hype becomes more difficult when it is framed around proprietary tracking data analyzed by SpaceX engineers. He urged people to look closely at the specifics he released, arguing that the details are both precise and deeply concerning. According to the data he shared, Atlas has executed 23 separate course corrections over the past 6 weeks. Each adjustment involved relatively small changes, velocity shifts of a few hundred miles per hour and trajectory angles altered by only a few degrees. Individually, these maneuvers might seem insignificant. Collectively, however, they have shifted Atlas from a trajectory that posed no threat to one that intersects Earth's orbital region. Musk published orbital calculations showing that Atlas's original path would have carried it past Earth at a distance of about 8 million miles, far enough to eliminate any realistic risk of impact. After the cumulative effect of those 23 maneuvers, the projected closest approach has shrunk dramatically to roughly 180,000 miles, a distance closer than the Moon. A SpaceX engineer involved in the analysis explained why this pattern raised alarms. Systematic adjustments that consistently reduce closest approach distance do not resemble random drift. They resemble intentional targeting. The critical uncertainty now is whether Atlas intends to pass by at that already alarming distance or whether further corrections will pull it even closer. Musk's concerns extend beyond proximity alone. He pointed to a specific point approximately 28 days from his initial warning when Atlas's projected position appears to intersect directly with Earth's orbital path. If Atlas continues following its current trend and performs additional velocity changes, it could align itself precisely with Earth's path at a moment that appears deliberate rather than coincidental. SpaceX tracking indicates that Atlas is accelerating at carefully chosen intervals that take advantage of gravitational assists from planetary positions. This technique, using planetary gravity to reshape a trajectory while minimizing energy expenditure, is standard practice in spacecraft mission design. Musk emphasized the precision of these maneuvers, stating that Atlas appears to understand orbital mechanics exceptionally well. Each adjustment seems optimally timed to produce maximum effect. This, he argued, does not resemble a natural object drifting passively through space. Instead, it resembles a spacecraft executing an advanced navigation plan, one that currently points toward Earth. Another aspect Musk highlighted is Atlas's changing velocity relative to Earth. Normally, objects on hyperbolic flyby paths accelerate as they approach a planet and slow down as they move away. Atlas, however, is showing velocity reductions that suggest active braking, as though it were attempting to match Earth's orbital speed rather than streak past at interstellar velocities. Musk included probability estimates in his analysis, concluding that there is currently a 12% chance of an actual impact if observed behavior continues. In planetary defense terms, this figure is extremely serious. For context, the asteroid Apophis once carried a calculated impact probability of 2.7% in 2004, which was enough to prompt global attention and emergency monitoring protocols. By comparison, Atlas at 12% represents a threat level several times greater. Despite this, NASA has not visibly activated emergency response measures. Musk stressed that SpaceX is not merely sounding alarms but actively exploring solutions. The scale of these proposals underscores both the perceived severity of the situation and the limitations of humanity's current defensive options. According to Musk, SpaceX engineers have been outlining rapid deployment mission profiles that could send spacecraft to rendezvous with Atlas and attempt to alter its course. Preliminary concepts include modified Starship vehicles equipped for kinetic impact or near-target nuclear detonation, the two most widely discussed deflection strategies. The kinetic impact method involves deliberately crashing a spacecraft into an object to change its momentum. NASA successfully demonstrated this concept with the DART mission. However, Atlas presents challenges far beyond DART's target. It is larger, faster, and, most importantly, capable of maneuvering. Striking a stationary asteroid is difficult. Striking an object that can actively dodge is vastly more complex. A SpaceX mission planner described it as akin to attempting to ram a fighter jet using a slower aircraft. Even reaching close proximity would not guarantee success, since Atlas could simply alter its course to evade impact. The alternative nuclear approach, detonating a device near Atlas to vaporize surface material and generate thrust, may offer more leverage, but it introduces serious complications. Deploying nuclear weapons in space would violate multiple international treaties, and Atlas's composition remains unknown. Without knowing whether it is rocky, metallic, hollow, or something else entirely, predicting how it would respond to such an explosion is speculative at best. Musk addressed these issues bluntly, arguing that treaties are designed for normal circumstances and that preventing the destruction of a city outweighs adherence to paperwork. Perhaps the most unconventional proposal involves creating a gravity tractor. This method would position multiple Starship spacecraft near Atlas, using their combined gravitational pull to slowly nudge its trajectory over time. While this is the gentlest approach, it requires weeks of sustained operation and assumes Atlas would not counteract the influence. SpaceX has reportedly conducted preliminary planning indicating that a trajectory modification mission could be launched within 12 to 14 days if approval were granted. Even so, that leaves a narrow margin within Musk's projected 28-day timeline. Some observers see a more controversial angle. Critics suggest Musk may be leveraging the Atlas situation to reinforce his long-standing advocacy for Mars colonization by highlighting humanity's vulnerability on a single planet. Whether his warnings are driven purely by concern for planetary defense or also serve SpaceX's strategic interests remains a matter of debate. Musk's statements have ignited tension with NASA, exposing deeper disagreements over how information about potential space threats should be handled. NASA's official response has been carefully phrased and restrained. The agency has stated that it continues to monitor Object 3/Atlas using multiple tracking systems and that current assessments do not indicate an imminent collision. It has urged caution regarding predictions from sources that have not undergone peer review. Notably, NASA has not released its own trajectory data or directly addressed the specific course corrections Musk highlighted. A former NASA administrator explained that the agency faces a dilemma. Publicly contradicting Musk could require revealing classified tracking capabilities, which might inadvertently validate parts of his concern. As a result, NASA appears to be relying on reassurance and hoping public attention fades. Musk, however, has escalated rather than retreated, releasing additional data and openly challenging NASA to publish its own models. He frames the issue as one of transparency, insisting the public has a right to know about potential threats even if that knowledge causes discomfort. The scientific community itself is divided. Some researchers support NASA's caution, pointing out Musk's history of dramatic claims and noting that SpaceX's tracking network, while advanced, does not match the breadth of NASA's global assets. Others argue that independent analyses are valuable and that governments have historically minimized risks until they became unavoidable. A space policy expert noted that this controversy reflects a broader shift. Private companies now possess tracking capabilities that rival or exceed those of government agencies, undermining traditional models of information control. Independent observatories worldwide have confirmed that Atlas is indeed performing course corrections. This fact is not in dispute. The disagreement centers on interpretation. SpaceX reports 23 maneuvers over 6 weeks, each reducing the closest approach distance. University observatories have independently confirmed at least 18 of these adjustments. Predicting future position becomes far more complex when an object can choose its own actions. As one orbital mechanics specialist explained, trajectory prediction depends on assumptions about future behavior, and with Atlas, those assumptions may be unknowable. What multiple sources agree on is that Atlas is currently projected to pass inside the Moon's orbit. Whether it safely skirts past Earth or moves closer depends entirely on decisions that cannot be predicted. This creates a paradox. If Atlas has the propulsion to steer toward Earth, it also has the ability to steer away. That raises a troubling question. Why approach so closely unless impact is intentional or part of some unknown plan? If impact were to occur, the consequences would be severe. Atlas is estimated to be around 800 meters in diameter. An object of that size striking Earth at cosmic speeds would release energy equivalent to thousands of nuclear weapons. While smaller than the dinosaur-killing asteroid, it would still cause devastation on a continental scale. Impact models suggest a crater up to 20 kilometers wide, with destruction extending hundreds of kilometers and global climate effects following. Yet even these projections are uncertain, as Atlas's composition remains unknown. A metallic body would be more destructive, while a low-density or hollow structure might reduce the damage. There is also the possibility of atmospheric fragmentation, similar to the Chelyabinsk event, though on a much larger scale. Musk has also raised a more disturbing scenario: deliberate targeting. A guided object could aim for densely populated regions rather than striking randomly. Military analysts consider such a possibility deeply unsettling, as a guided kinetic impactor would be extremely difficult to stop. Another speculative possibility Musk briefly mentioned is that Atlas might decelerate into Earth orbit rather than collide, representing a form of first contact rather than impact. Throughout this debate, Musk has reiterated his belief that humanity must become multiplanetary. He argues that existential threats, asteroids, nuclear war, climate collapse, pandemics, and uncontrolled artificial intelligence, make reliance on a single planet dangerously fragile. Critics accuse him of exploiting fear to advance SpaceX's Mars ambitions, while supporters note that he has advocated this vision for decades, long before Atlas appeared. Musk has even suggested that Starship could be used to evacuate key personnel and genetic material to Mars if an impact became certain. While ethically fraught and deeply controversial, he argues the technical capability may exist. As the 28-day window approaches, uncertainty continues to weigh heavily. Musk posts regular updates, some reinforcing concern, others noting stability. NASA's messaging has subtly shifted toward acknowledging ongoing monitoring without fully dismissing risk. Independent astronomers have formed a global observation network, but even with that coordination, decisive warning could come only days or hours in advance. Some governments have quietly reviewed evacuation plans, particularly in coastal regions vulnerable to tsunamis, though such preparations remain unofficial. The reality appears complex and uncomfortable. Atlas is unquestionably steering closer to Earth. Whether that path leads to impact, a close pass, or something entirely unforeseen remains unknown. In less than a month, the outcome will be clear. Atlas will either pass safely, collide with Earth, or surprise humanity in ways no one predicted. What is certain is that an object from another star system is approaching our planet with intent we cannot yet understand. Whether this warrants panic or simply cautious preparation is a judgment each observer must make for themselves.